In the couple of previous lessons in this chapter, we were mainly focused with authentication in our REST API, which mainly deals with proving who the current user is and making sure that this user should have access to our REST API. Now, as part of this lesson, we will start talking about authorization, which deals with what the current user can do. Our focus will be protecting the resources of our API from unauthorized access by other users and only allowing the current user to access the resources that they own. So let's jump into the code and I'll show you how we will implement this. We are going to start from the user's controller, where I want to implement a special get endpoint. This endpoint will allow the current user to obtain the representation of the user DTO. So let me copy the implementation that I have here and let's use it to create another endpoint. I will call this endpoint getCurrentUser, and it won't have any route parameters. In fact, it won't have any arguments at all. The route will be just me representing the current user, and then we have to figure out how we will find the user's identifier. Now, because we have access to the HTTP context, I can access the claims principal property. And here we can call the findFirstValue method, which allows us to specify a claim type, and I want to use the name identifier claim. This will give me back the user ID claim, but this is actually the identity ID. So let's rename this to identity ID to properly represent what this is. Now, if string is null or whitespace identity ID, then something went wrong and the user should be rejected. So let's return a 401 unauthorized response. Now, if the identity ID exists, I can use it to filter out the users table and get back the user DTO. Let's quickly test this out. If I send a GET request to our new endpoint with this URI, users/me, we will get back a 200 OK response, and this response contains the information about the current user. Let me take the user's identifier and use it when accessing the getById endpoint, and you can see that we get back the same response. So a new endpoint is working, and it allows the current user to access this information. Now what I want to do is to register a new user, and let's call it Milan1, send this request, and I get back an access token. Now I can use this access token to set it as the token on the collection level, and if I send a request to get the current user, you can see we get back a different user ID because this is a new user and the email is different. But if I try to access the user using the ID, and if I specify the identifier of the other user and send this request, I will get back a response. And something like this is a problem, and it exposes your API to security vulnerabilities where anyone can access resources that don't belong to them. And this is what I want to solve as part of this lesson. Let's start by making a couple of improvements. First, I want to have a simple extension method that will easily allow me to get the identity ID from the user's claims. This will be useful when we switch out our identity provider for something else. So let me create a new class in the extensions folder, and I will call it the claims principal extensions. This will be a static class, and I will define a static method inside that's an extension method on the claims principal type, and it returns the name identifier claim, which represents the identity ID of the current user. Then I will introduce another service, which I will add in the services folder, and let me call this the user context. The user context will allow me to get the identifier of the current user within the context of our application and not the identity ID. So let me unpack what's going on within the user context. First, let's examine the dependencies. I'm using the HTTP context accessor, the application database context, and the iMemory cache. I'm exposing just one method called getUserIDAsync, and inside of this method, I first extract the identity ID using the HTTP context, accessing the claims principal, and our new extension method. Then I'm going to construct a cache key using these values, and finally I will use the memory cache to call getOrCreateAsync, pass in the cache key, and define a factory for how I actually obtain this value. And what I'm doing here is querying the users table, filtering by the identity ID, which is a unique value and belongs to the current user, and I'm extracting just the ID of the current user and returning that as the value that I want to cache. So this exposes a simple API for me to retrieve the identifier of the current user. Now I'm leaving the possibility that this could be null for whatever reason, and in that case I will return 401 unauthorized. So if we go back to our users controller and inject the user context as a service, this will allow me to update my implementation below. So let's rename this to be user ID. And we're going to get this value by saying user context, get user ID async, and we get back the user's identifier. Now I need to update this to filter based on the primary key column instead of the identity ID, and now the functionality is the same. Now let's copy this into our above method, where we are fetching the user by the ID, and what we want to do is to make sure that the user ID value that we get from the claims, which we derive from the JSON Web Token, is the same value that was passed in the route, which will make sure that this is the current user. So we want to check if these values are different, and there are a couple of ways how we could do this. So first, let's say if I manually do this check, then the correct status code to return would be 403 forbidden. From a semantic standpoint, this is the most correct status code to use, but what this also does is it communicates to the client that this resource does exist, but you don't have access to it. Now, depending on your use case, this may or may not be what you want to do. An alternative would be to omit this check, and once you fetch the user, you can also add a check to confirm that the user ID values are equal. Or in our case, if they are not equal, then we want to return 404 not found, for example. Let's stick with the most correct approach and return 403 forbidden. Now I will need to register a couple of services for this to work. So let me go into dependency injection, and inside of the add application services method, I will say builder services add memory cache. We are already taking care of the HTTP context accessor. And let's also say builder services, and I will say add scoped and expose the user context as a scoped service that you can only access within the scope of the current request. So now let's start the application again, and let's send a request to fetch a user by the identifier, but we are trying to access the information for the user who is different from the current user. And if I send this request, we get back a 403 forbidden response. Now let me go to the users/me endpoint and resend this request. And if I take the identifier of the current user and use that in this request, then we will get back a 200 OK response. So you can see that our initial implementation for protecting our resources is working as expected. Now let's extend this to our other resources. I will start from our two domain entities, the habit and the tag. So we have to introduce an additional property here, which is going to be the user identifier. This will be the foreign key pointing to the user's table. Let's do the same for our tag. After the ID, let me define another property representing the user identifier. Then I need to update the configurations for these two entities. So let's go into database configurations, and let's start from the habit configuration. I want to define a max length for the user ID property, and let's use the same value as the primary key, which is 500 characters. And then let's configure the relationship by saying builder has one, and we specify the user. The user, on the other hand, can have many habits. Then I'll specify the foreign key, which is the user identifier, and this is enough to configure the relationship. Now let's do the same in the tag configuration. I'll add a max length for the user ID property. I will add a relationship. Builder has one, specify the user. The user can have many tags, and the foreign key is the user ID property on the tag entity. Now another constraint that we have to impose here is the uniqueness of the tag name, which should be scoped to each user. So if I update this index to also include the user ID, I can make the tag names unique for each user, meaning different users are allowed to have the same tag name. Of course, we will also have to update our controllers to accommodate for this. Now let's go ahead and create our database migration. So I will say add migration, and let's call it add user ID reference. The context will be the application DB context, and the output will be migrations/application. If I update my startup project and execute this command, I will get back my new migration. This migration will also reorganize our existing tables, and the problem you will run into if you try to execute this right away is if you have any existing habits or tags in the database and we are adding a required column, then we risk ending up with invalid data. So I recommend that you update this migration by saying migration builder SQL, and I'm going to add a SQL statement that's going to delete from the habit tags, the habits, and the tags tables, and only after that we're going to apply our new migrations, which is adding the new columns and creating the respective indexes. This will also include the foreign keys to the users table. So when we start the application again, this migration will execute and we can continue working with our updated database structure. Now let's close this down, including the two configurations and our entities, and I will go into our controllers. For example, we can start from the habits controller, and then let's see what we need to do to protect these resources and only make them accessible to the current user. So I'll start by injecting the user context into this controller, and then I just need to update all of my existing endpoints to access the user ID of the current user and use that when filtering our database. So here I have to add a where statement before any other where statements to confirm that the user ID is equal to the current user's identifier. Let's go ahead and do this in our get endpoint. So right here, I fetch the user ID, and here I will use the simple route and confirm that the habit user ID is equal to the current user ID, and if that is not the case, then I'll just return a 404 not found response. Let's do the same in our remaining endpoints. This is our version 2 of the same endpoint, and I have to add this condition that the user ID is equal to the current user ID. Let's skip the post endpoint for a moment and focus on the put endpoint. Here I will also confirm that we are accessing the habit as the current user. Let's do the same in the patch endpoint and add the same filter. And let's do the same in the delete endpoint, and we will add the same filter. Now let's focus on the create endpoint. What we want to do here is also grab the current user's identifier, but we want to add it to our habit when we are creating it. So I can, for example, pass it as an argument to the toEntity method. Let's expand this to include a user ID argument, and this will be a required value. And then I can just set this value on my entity when I'm creating it. And this will make sure that whenever I create a new habit, it's associated with the current user. Now, what is the alternative to this? With this implementation, we don't have to change anything about our API contract. We are still exposing the post habits resource, and we don't need to complicate this by, for example, having to include the user ID as a query parameter, or even include it as part of the route. Now, if we wanted to make it a part of the route, then this would significantly complicate our implementation. For example, the route could be users/user ID and then /habits, but this only leads to more nesting without making our API any more usable. We will have to authenticate with our API anyway, and we can use this to obtain our contextual information to figure out who is the current user. So I think that the current solution is the pragmatic one. Now I'll go ahead and do the same in the tags controller, and now we can start our application and test out if this is working as we would expect. I will log in with my default user account. Let me take the JSON web token, and I will set it as the value when authenticating on the collection level. Now let's try to create a new habit by sending a post request with this request body. We should get back a 201 created response, and this even includes hypermedia links because I specified our custom media type. So everything seems to be working. If I try to access the habits resource, I'm getting back a response which contains the one habit that I currently have. Let's go ahead and create a tag. So let's say I create a .NET tag. I managed to create it successfully, and let me use the upsert habit tags endpoint where I will assign the tag that I just created to the one habit that I have. Let me include the ID here to grab it from the response, and then I'll specify it here, and then I will use this tag identifier to pass it as the argument in the request body. I'll just specify one tag, send this request, this succeeds. Let's again use this habit ID to get the habit information. Let me specify it here, and in the response, if I check out the tags, the .NET tag is present. Now let me go and log in as my second user, so Milan1, grab the access token. Let me specify the access token value. I'll paste in the token value here, and then if I try to access the habits, you will see that the current user doesn't have any habits because we are doing implicit authorization to only return the data for the current user. If I try to fetch the habit by the ID, you will see a getBack 404 not found because this habit doesn't belong to the now current user, and the same applies if I try to fetch the tags. You will see that the collection of tags is empty because the current user hasn't created any. So we can confirm that our authorization implementation that checks for resource ownership is working as expected. But this is only scratching the surface of what we can do with authorization. In our next lesson, I'll show you how we can implement role-based authorization support using ASP.NET Core Identity.